Hello and welcome back to the Ever-Forward 3D Printing channel. In this installment, we're going to be looking at different technologies that have been referred to as 3D printing. Just as we explained in the first video, there's a term additive manufacturing, and 3D printing is one component of that. But when we say 3D printing, we don't always mean the same thing. We could be talking about an FDM technology printer, SLA, SLS, MJP. Any of these could be called 3D printing. You wouldn't be wrong, but they're very different from each other. And so in this video, we're going to break down the different technologies and help you understand the pluses and deltas of each.
This list is not meant to be comprehensive, but these acronyms that you see on the screen cover the wide variety of printing technology that's out there today, and we'll talk about the last one, multi-jet fusion, which is still emerging. So FDM, fused deposition modeling, SLA, stereolithography, P-jet or polyjet, M-jet or multi-jet, not to be confused with polyjet, SLS, which means selective laser sintering, and then M-core is not the acronym for the technology, but that's the name of a company that has a proprietary 3D printing process. We'll talk about that, as well as the multi-jet fusion or MJF. So fused deposition modeling, this is a good entry point technology. I was able to print this phone case using a printer that cost me less than $1,000. And as you can see, the definition on that, and you can see the light kind of coming through what should be the solid parts and pieces. It's not an exact science with FDM. There's always going to be some noise, and you may not get the same print twice. There are more expensive, higher end printers that do fused deposition modeling. I think the most expensive, you'd be talking about maybe a $20,000 printer at this point, but you can do more accuracy with something like that. FDM is popular because it's relatively inexpensive, but also you can print this wide variety of materials. For example, I've made this little wood palette out of a wood substrate material. There's also metal, conductive metal. There's different types of plastic, like food grade plastic, sandstone, rubber, faux glass. So it seems like every week there's a new material that somebody's figured out to make a filament for and make that some other new material you can print using this FDM technology. There are definitely some downsides. It's not the most accurate. One common problem, as you can see in this last print I'll show you here for FDM, is how the corners on the bottom of that print all warped, and that took about 7 hours to get that thing off the machine. The corners were warped, and that made it less usable. I was also trying to replicate what was in a SketchUp file, which had a lot of nooks and crannies in this piece, and it had to print what's called support material, and because I only had a single extruder on my printer, it all had to be one material. So the only feasible way of actually cleaning out that support material would be to get a drill or some other tool and just start cutting and scraping, which kind of defeats the purpose. So FDM, I would say, relatively inexpensive. A lot of users, a lot of models out there meant to be just downloaded and printed FDM, and unfortunately it is not particularly fast. It's not particularly accurate, and although there are FDM printers that can handle the multi-material, or can print more than one substrate, they've got to be two things that print at the same temperature, which limits that. It's also not particularly easy to set up and configure the printing files for multi-material. Stereolithography is an exciting technology to me. It's a little bit confusing because the most common printable file uses a file extension called STL, which means stereolithography. But the technology of curing a liquid into a finished part, for some reason, although that is stereolithography, the acronym is SLA. So SLA, STL, one refers to the printing or printer technology, the other one refers to a file type, but they both mean stereolithography for what that's worth. This Coke bottle was printed on a very high-end, expensive SLA printer. I held it in my hand. I couldn't distinguish that from a Coke bottle made by any other process. The smaller model was made on a less expensive SLA printer. It still has very good detail and resolution. So I like SLA because of the ability to print with a high accuracy. Also, the material is relatively low cost. There are low cost options for SLA printers. I picked one up for, if you can believe this, for $200. It doesn't have a very large build area, but I've got at least an SLA printer on my desk. But there are some things to be aware of. The liquid resin is not considered safe. You don't want to get it on your hands or anywhere else. Also, because the whole basis of the technology is light curing a liquid resin, as you could imagine, you can't leave these parts. This little architectural model would probably melt or burn up or just crumble if you left it out in the sun, or if you left it on a windowsill or something where it could receive too much light. I'll just show you quickly here the level of accuracy you can receive with SLA on a less expensive printer. So it's another good entry point to consider for somebody getting into 3D printing. Now, there is a technology that most people refer to as simply 3D printing, and it's different from the ones I've covered so far. I don't think anyone's come up with a good way to explain powder and binder as a process, but essentially a commercial 3D printer that's quite common uses a powdered plastic, and it just puts down a layer of that, and then some sort of print head comes along and cures part of that with a liquid binder, and then it will lay down another very thin layer of the powder, and then the binder is applied, and then powder and binder, and what ends up happening is you have a print which contains all of the leftover powder. And you can see this was an actual print that we had ordered here at DPR some years ago for a completed project, and it wasn't planned properly with escape holes at the bottom to, or at least there weren't enough of them to get all of that leftover powder out. And so at one point this cracked. You can see the powder that was left behind, and it's still quite heavy, even with as much as we've shaken out of there, that it's still heavy to pick this thing up because there is so much trapped powder. So this is, again, more of a commercial process. The PolyJet refers to the ability to print color, so that's a good option. It's I want to say kind of a baseline for commercial printing. You get the good resolution, good accuracy, that is, you get good durability, you get the color. What kind of turned me off to this was the first time I went to a vendor shop and saw them printing using the powder and binder process. And so they had a nice showroom. They've got this expensive machine and it's putting together a model. And one of the sales guys said, "Okay, now follow me." And they went into some back warehouse, and they had several stages of post-processing for the model, including dropping the whole thing in a bath of glue, some cyanoacrylate glue, for a long period of time to cure the thing. And I just thought, well, again, where's the advantage in 3D printing when you use this technology if you've got to take all these additional steps? So not a bad option for the commercial print house that's going to make you a model, reasonable model at reasonable cost. But I don't foresee, most of us, either, as a hobby or as an employee of the company, saying, "Hey, let's go get one of these types of printers," and then have to, deal with all the post-processing that's involved. Multi-jet, also not to be confused with PolyJet. Multi-jet because it can print, as many pieces as it can fit on a print bed, as in the same amount of time as it could print one. I don't think this technology is particularly relevant to us. I think it's more for jewelry and other fine objects. You can get the very best resolution without warping, but a lot of times that's because it uses a support material that is wax, and then you have to kind of melt out the wax or figure out a way around that. Or it can be used for in what they call lost wax casting, where you make a part that's wax, and then the intended final material takes the place of the wax, and so you lose that wax. Again, not something that I see a lot of advantage in for us. I mean, it's great if you had to, print 100 little doodads that are exactly the same. And if you really wanted high accuracy, they say this goes down to about 1/3 the width of a human hair. That's pretty good accuracy, I think. But again, not particularly for us. SLS, or selective laser sintering, has some similarities to the powder and binder and also to the SLA process we talked about earlier. But really what this does is it takes the very small, fine particles of a material and fuses them together. It's almost like welding together at a microscopic level the part that you want. And what I'm holding in my hand here in this picture, that's a real air duct, piece of an air duct that would go into a commercial airplane. You may also have seen or heard of doing SLS with metal. And so unlike other versions of 3D printing where you might print some other material, maybe it's the wax, and then you pour the metal in and get rid of the wax, this is direct metal. And so you may hear somebody talk about DM. And so they're talking about an SLS technology where they are taking very fine grain metal and the laser is just fusing that all together, and you can see this kind of building facade, which looks every bit as good as like a die-cast metal part or something. Very high accuracy, very high strength, really comes out as one piece and uses less material than other traditional methods. So that's some of the advantages. As you can imagine, SLS, especially if we're talking about metal or that sort of thing, is going to have a very high cost. And it's not particularly fast. It's not particularly accurate. I mean, some of these other technologies actually get higher accuracy, but for the uses that we've shown, SLS is quite good. So MCOR, not a technology, but rather a company, and their process is to print using paper. So if you can imagine, you lay down a sheet of paper, the printer goes and scores or cuts that at the appropriate place, and then if necessary, it can use an inkjet to apply color. I don't believe this example that you're seeing was color being applied to each sheet, but rather just different color sheets in a process as they developed that sphere. So what happens is you're using paper, you're using ink, it will just cut and then, if necessary, color, and then press and glue that sheet of paper onto the stack. And when the entire stack has been printed, you just manually rip or pull apart the parts you don't want. So very exciting process. However, it has been difficult to track down any real salespeople for MCOR and get answers. They recently released a new desktop version of their printer technology, so I've been trying to see if we can get our hands on one of these. So finally, I want to mention multi-jet fusion, and this is really just HP getting themselves into the 3D printing game. They've been talking about this for well over a year, and I have seen some videos and some examples. I can't really give you a plus delta, I think, on this. It's still too early, and the process is still emerging. But as I understand it, essentially, whatever base material they use, there are two different types of liquid agents that are applied and then fused. And so that allows for a variety of surface textures, a variety of material strength or finish as needed. And supposedly the big deal is the speed. They talk about running circles around any of these other technologies in terms of time to finish a print. So if that is the case, then it becomes very interesting. We still don't have a good handle on price of either a printer or the price of a finished print, or really any actual metrics or numbers on the speed. But we'll continue to keep our eyes on this technology and any others that are emerging. So that's it for this video. Thanks for watching, and I hope you enjoy other videos on the Ever Forward 3D printing channel.